All right, so there are 1, 2, 3, 4, 5 slides we're going to do. So each slide probably is going to take up this roughly the same amount of space. So as you're making this, you may want to keep that in mind. Is that too dark for you guys? Okay. So I looked at my test from last year, and there's a Post-it note on it that says students either did really, really well or really, really bad. So that made me kind of nervous for you guys, because basically that means is if you've been doing your work and you study tonight, that you'll be fine. The flip side of that is pretty obvious, I think. If you haven't been working hard and you haven't been doing your work and you don't study, you're going to score really, really, really low. I don't know if that motivates you to not do that, but I'm just putting that out there so you guys know that this test is going to be really hard if you don't prepare for it, and not that bad if you do. Okay, so transformations. What does that word mean? Say again? Yep, transforming into something different. So just so we know, here is the test, and basically I'm going to look at this and go, yeah, you need to know this, you don't need to know that. So this is good stuff we have today. So if you don't know some of this stuff, you really need to kind of pay attention. Transformation means how does it move? How does it change, right? So transformers transform from one thing to another. They're still the same thing, right? Okay, so let's just come up with an example. If I gave you y equals, somebody give me a number. -2, x minus 5 squared plus 4. Thank you. Transformation means from the parent function, which is the basic y equals x squared, how would this thing have been different? Okay. First question on the test says, tell me the transformation of this thing. Transformation, you would say what? What would I say about this negative? Okay, flipped down, or even I guess flipped is fine. I'm gonna put down. Maybe even draw that. Okay. Really, the book if you looked it up in a book, it would say it was reflected down, but that's fine. What is the 2 going to do? That's the first slope. Okay, so the 2 is going to make it. The first slope is my language. I guess I'd be okay with that, but it affects how steep it is. It's going to be more steep. Okay. Than this. Okay, it's going to be more steep than the parent function. The parent function would be this. This one would be a little steeper. The book uses words like stretch, compressed, flexed. Every book uses different words for this. I like first slope. It definitely gives you an idea of that, okay, if it's a bigger slope, then that just means that first point is going to go up faster. What does this 5 do? Right, how much? Okay, that's a dumb question to say how much. It's pretty obvious, but you need to say 5. No, I am a horrible speller, so you'll get away with.
I just forget some of the stuff from yesterday. I remember that number. But where's the current tax?
It's on that other sheet. And then finally, the +4. So that number came from adding these or adding those. So single people, this is what you deduct for the current plan. This is what you deduct for the Trump plan.
Okay. So like current tax?
So that'll come from timesing these 2.
Oh, right. And then the Trump tax is after deduction, so that'd be that number.
Mm-hmm.
From the big number.
Mm-hmm.
Okay. I got
get that. Okay. What do we say about 4? Up 4. What have I just written down? What's in blue there? It's the transformation. Okay, so some people are going, hey, it's saying, what's a transformation? People were confused by that word. Okay, transformation just means how did this thing move from its parent function? Okay, that's it. Next big concept is the graph. And all of these things, when you go back and you want to study tonight, you can find every example of every one of these things I'm about to show you. Okay? Nothing here is a mystery. So, graph. Give me an example. Y equals, give me a number, -7. X plus 2. Give me one more number. -3. I like the energy. Okay. So then I put on here, and a lot of people are, again, kind of confused. And basically what's going on here is we have all these little ideas. We know all these different things, and I'm kind of asking you to put them all together now. Okay? How does this affect this? How does a transformation affect the graph? How does the graph affect the vertex? All these different things kind of coming together. 90% of the time, the answer is with the vertex. Okay? So, having that been said, what do you think the most important point would be here? Okay, no? 90% of the time, the answer is the vertex. What do you think the most important point is? -2, -3, aka, what is that? The vertex, okay? Finding the vertex. Because if I graph this thing and don't write what I'm about to do, but if I were to plot 3 points, 1, 2, 3, that's not enough to know what's going on. I have to know if I plot the vertex and 2 other points, boom, I can draw that. Okay? If I draw this, I don't know how far down I need to go. I need that bottom or top point. So -2, -3 is important. Bam. So I need points on either side of the vertex. What do I mean by that? Give me a point on either side. What's that question? Okay. Are you sure? Ask it, please. Okay. That is a -2 and a -3. So I think that's the question that's popping up. What? No? Oh, mercy. Doing the best I can, people. Okay, no, just kidding. Thank you. Is that what you're going to ask? You just assumed I was right. That is weird because that's the first mistake I've made in 15 years of teaching. That is a lie. Thank you for pointing that out to me. All right, so -2, -3. A point on either side. What x value do I need to find for a point on the other side? No. 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 Say again? No. -1 and what? I like -1. Give me another one. Point on both sides. -3. Take a second and answer this question in your head. What does that mean, a point on both sides? Why is -1 and -3 a point on both sides? Because it's around it. Yeah, it's around it. So if this number here was 5, if this was 5, what would you think I would want on both sides? Well, +5, 4, and 6. Okay, whatever that number is, you need to give me one more and one less. Okay? And we got to figure this out. The vertex answer, this answer here, is just sitting here, right? These answers are not just sitting there. We got to figure them out. So, okay, we got -10, but how do we figure that out? What I'm going to do is I'm going to come up here and I'm going to plug in -1 for x. So everyone try this in the calculator so they know that they can do this correctly. If you can't type this in the calculator correctly, sad things will happen tomorrow on the test. -7, parenthesis, -1 plus 2, parenthesis squared minus 3. What's that spit out at us? -10? Is that what you're saying? -10. Good. And then I want to do -3. Okay. And it should be the same because you went exactly the same distance both ways. Okay. And we get -10. What do we call this number here? What do I call it? Not just the slope, but the what slope? First slope. What do you notice happened with these numbers? They both go down 7. Okay? That's going to happen every time. That's what the first slope does. The second number away doesn't follow that rule, but the first one does. If you know that, you can just say, oh, just subtract 7 from both these numbers. Okay? Or you can plug them in. You also can graph this when you're done to make sure that it matches what you have on your paper. Okay? There's a lot of tools that you have for this. -1, -10. Okay? So -10, 3, 4, 5, 6, 7, 8, 9, 10. You'll get a graph on the test. And then I just got to connect the dots. And what's important on this is that I'm clear that it's curved. Okay. It should not be a V shape, not straight lines. It should be kind of have some curve to it. That's what I mean by graph. We had some questions in our packet where it said graph, and it looked a lot like this, and that's what we're looking for, is that vertex is our starting point. Our vertex tells us a lot of information. Our vertex is always either a max or a min. It's important. Parts and pieces. What the heck does that mean? So parts and pieces means all the different aspects that I keep asking you to find when we do these problems. Okay, so give me a number. -5, x plus 6 squared minus 7. Okay, 5, 6, 7. Very creative. Okay, so the test, I'm looking at it, it says, given this function, find all the parts and pieces, and then it labels them. Okay, so somebody give me one part or piece that we keep asking for. The vertex. Okay, I always like to start with the vertex. What is the vertex here? -6, -7. Okay, whatever these numbers are sitting right here is the vertex. Right? There's a vertex, except we've got to, when I'm with my x, this is what I always say, when I'm with my x, I do the opposite, so that +6 becomes a -6. What other parts do we ask for? Axis symmetry. What is our axis symmetry? Careful, it is -6, but x equals. I will take off points if you don't say x equals, because just -6 is a point. X equals -6 is a line that goes straight up and down and cuts this thing in half, and that's what we're trying to do. What else do we always ask for? Max or min? Is it a max or min? And how does she know it's a max? Okay, this negative right here tells me that the graph goes like this. So that means that we have a max. Okay, that's actually how it is on the test. It says circle 1, max or min. What else? Range. Before range, I usually ask for what? Domain. What's our domain? Yeah. Right there in the center desk. I'm sorry, right up here. Yeah. Yep. Okay, so let's talk about this. If this is a drawing of this thing, we would put dotted lines on the sides, on the none on the top. This would be a solid line, dotted line, dotted line. Okay, correct?
Career Academy students, if you have turned in a permission slip to attend the Otterbein visit, please report to the cafeteria at this time.
Let's do one thing before we jump, before I talk about domain and range. What is our max? We said it's a max. What's our max value? -7, okay? And that comes from here, okay? So now going back to this graph, what's the number I put on top here? -7, because that's our max value. That's how high it goes. And all the dotted lines are what? Okay? And I think the hardest thing to understand here is that it's going to break through on the sides. When we started playing that game where we put the box around it, a lot of people did not think that it broke through the sides, but it definitely breaks through the sides. It keeps creeping to the left and the right. Which of these are negatives? Okay. So domain is right here. So negative infinity to infinity. And range is what? Good. Negative infinity to -7. Probably not going to stress brackets, parentheses at this point. I'm showing you the right way, but if you have those incorrect on the test, I probably won't take off for it. Yeah, so the range is here and here. Okay. I think that quick drawing is super helpful. X symmetry, vertex, max or min, max min value, range, domain. We did all that, right? Okay, good. I like the order we did this in. This isn't the order they asked the questions. I personally think that finding the vertex is the first step for these. 90% of the time, the vertex will help you out with the answer, and then going from there, okay? Any questions on that? Okay. If I were to make a cheat sheet that I wouldn't be allowed to use on the test, but something I'm looking at as I'm walking in, it would be this sheet. And one thing I would point out is, like, you know, things like that this number comes from here, and that this number comes from, or goes from there, okay? That kind of correlation. Next, this is probably the hardest part of the test for a lot of people. So vertex form, every question that we just made up, it's in vertex form. Vertex form is really nice because the vertex is just sitting there, hence the name vertex form, right? Vertex form because the vertex is sitting there. I could circle it, I could erase things, and boom, there's the vertex. When I don't have it in vertex form, it's called standard form. That's the way the calculator spits it out at you when you do the regression models. So we have to know how to switch from vertex or standard form to vertex form. So this is, there'll be a problem on the test that says something like this. And it'll say, give me, translate this to vertex form. How do I know this is not the vertex form? Doesn't have the parentheses. That's a big hint. How many x's are in the vertex form? How many times do I write x when I write the vertex form? If I will go back to the last problem, how many x's did I write in that very first problem? How many did I write in this one? 1. And how many times did I write x here? Okay, so vertex form, you only write x once. How many times did I write x there? Okay, that means it's not in vertex form. Okay, so vertex form, what our goal is to get y equals a parenthesis x minus h squared plus k. And I honestly hate this formula, the way it's written. I hate h and k. Okay, that y, h, y, k. I don't know, it just bugs me. Okay, but we'll go with it. Sometimes I write this as a plus sign. Okay, Sometimes I'll write that as a plus sign. It's kind of up to you how you do that. Okay, so we need those three numbers. We need to know what H or A, H, and K is. Okay, do we know any of these parts? We know A. Y equals -3. A on this equation is the same as A up here. This is the same thing as this. Okay, on the test, if you do just that, boom, you get some points. Okay. Now we got to figure out H and K. 90% of the time, the first thing you should do is what? Find the vertex. Vertex, vertex, vertex. If you're looking for the vertex form, I would hope that you'd find the vertex. Some of my best friends are vertexes. Is that a question? That's a stretch. Okay. How do I find the vertex? So we have this weird formula that says take -b over 2a. You kind of have to know that. And that's the first part of our vertex. Just have to know -b over 2a. So what we're going to do here is we're going to identify this as my A, B, and C. Okay? And we got to figure out what we got going on here. So -24 over 2 times -3. Now when I type this in the calculator, you got to be kind of careful because when there are two things in either the numerator, the denominator, or the top or the bottom, you have to put parentheses around it. If you want to just type this whole thing in, again, you have to put parentheses around this. Okay. Personally, I would calculate that bottom and then start dividing and stuff. Okay. But let's type this whole thing in. Everyone try this because I want to make sure that you're not going to make a mistake on this tomorrow. So what do you get when you do -24 and divided by that stuff? 4. +4. Okay. So now I know that I have 4 is the first part of my vertex. I just answered which part of the question, my final question? The inside. So that's going to be what? If this is a +4, this would be a negative because this is the one with the X. Remember, when you're with your X, you do the opposite. Okay? If you do not get +4 there, it probably has something to do with the bottom getting messed up. I personally would type in -24 divided by -6 or do those separately. Okay? But make sure you understand how to do that. What do I do with this 4 now? Plug it back in. I plug it back in for X, both here and here in the original equation, and it's going to tell me the other part of my vertex. So in the calculator, and this is getting kind of sloppy, I apologize, but -3, 4 squared plus 24 times 4 minus 43. What does that equal? Everyone try this so that we know that we can do this. 5. Anyone else get 5? And I just found what? Okay. And where does that go down here in my final equation? Okay. Would it be positive or -5? +5. Okay, remember that the second one. How could we check this answer? A 100-point test. It's a big test. How could I check this? There's only like 6 questions on it. 7. Yeah. So every question's like 15 points. No pressure. How could I check this?
You just don't. You just, if it's right, you just write something down.
Okay. How could I check it?
You could just like plug in a random number.
I love it. Plug in 7 up here and plug in 7 down here and see what happens. Gives you the same answer. Makes me feel really good about it. I like that. Okay. Worth checking. The only thing that makes you crazy is when you check it and you realize it's wrong. Then you're like, now I got to go find my mistake. Okay, it can be challenging. Just to recap, Steps on this, step 1 is to find the first part of my vertex. This is all kind of step 1. And then step 2 is to plug that thing in. And then step 3 is to kind of put it all in this. Honestly, on this, I would be okay if you just wrote down the vertex and the answer. Because you can do this in the calculator, and you can do this in the calculator. Okay. The only advantage of showing all your work is if you make a little mistake. If you just write down this and it's wrong, it's hard for me to give you any credit because I don't know what you're doing. Okay. I think this is the last thing, regression. Yep. Yeah, please.
So did you start with a vertex form and then change it to a standard form? Or?
No, the only thing I'm going to ask you to do is I'm going to give you this standard form and ask you to give me a vertex form.
So that was a standard form?
This is the standard form and right up here, yes. Okay, this is the only thing I'd ask. Because the vertex, and this is the point I was trying to make on that sheet where you compared, and this is the problem where you compared this version to that version. The red version up here doesn't really tell you anything, okay? That's kind of a bad version. And my point being is if you have the vertex form, you're pretty much never going to switch it to the other one because this is the vertex form is the better form, okay? Regression. So we have that football question. There is a word problem question on there. There's a bunch of regression. There are 3 questions on regression out of 7. So regression is just simply where I give you ordered pairs or values. You got to create a list L1 and an L2, and then you got to punch it in the calculator following those steps. Something you need to know about both regression and this last thing is that I don't give you any formulas on the test. So for example, that formula is not on the test, or how do the steps of regression is not on the test. You just kind of have to know which buttons to push. We did it in that little box. Do we want to do a regression problem together? Sure. Sure. Football one? Okay. Football. Probably a really good idea. I think somebody yesterday said, I don't play football. Yeah. Cleveland Browns are playing their last game of the season and are down 2 points with 4 seconds left on the clock. The ball is kicked from the 32-yard line, so it will be a 42-yard kick, 10 yards for the end zone. Do you guys understand what I just said there? Okay, because you don't know football? Okay. So in football, it's like this weird-shaped ball, okay? And you can get points by either you could throw it into the end zone and someone catch. Well, your team has to catch it. Okay. Okay. So what I recommend is drawing a picture, and I drew a picture on the board. I'll draw it again. Is we have the Cleveland Browns, which so far have a perfect season.
Really?
Yeah, they haven't won a game, so they're perfectly defeated. Okay, and to win this game, which they won't, they have to kick this ball. And what shape does that make when they kick that ball? It's like a U shape. Why is this in this section? Because it's a U shape, the ball being kicked. Okay. We're told that the distance the ball is from the field goal post is 42. So this distance right here is 42. 32, it's on the 32-yard line. The goal, for those who don't know, here's the end zone line, and there's always 10 yards past that, and they put it there so people don't run into it when they're trying to catch a ball in the end zone. So even though it's a 32-yard line, you have to kick a little further. Okay. It says that after 2 yards, the ball's 5 feet in the air. Okay, so after 2 yards, so say right here, it's going to be at a height of 5. And after 10 yards, it's going to be a height of 21. Then it says make a chart, answer some questions. Okay? The hardest part about all of these is making the chart, knowing what the L1, L2 is. When you make your L1 and L2, you have to say that they're the same things. Okay? Some people just started grabbing numbers and putting it in their chart. Okay? So the numbers that they first gave you, that it said we're down by 2 points and there's 4 seconds. Okay? So some people put that here. Well, that's fine, but then this category becomes points, and this becomes seconds. Where else do we talk about points and seconds? Nowhere. So we can't use that. That's not any good. Whatever we decide to label up here, points and seconds, has to be, we have to have a bunch of points that describe that. Is there any situation where we say, oh, it's this at this point, and it's this at this point? Where? Good. So right here is the only time that we say the same thing more than once. We say after it's gone 2 yards. Okay? So this is my distance. This is going to be my height. Oh my gosh, I can't spell. Okay, so after it's gone 2 yards, it's 5 feet off the ground. After it's gone 10 yards, it's 21 feet off the ground. Okay, I give you a hint. You have to have a third point. Where would our third point be? It's tricky, but it's 0, 0. Okay, you can almost always use in word problems the starting point as a point, 0, 0. Before the ball is kicked, it's on the ground and it's gone. It's 0 height and it's gone 0 distance. There's our L1, L2. Okay, now we need to follow those steps. Okay, try that. See if this is a test right now. Could you do this regression? Try it without looking at that little chart. Anybody lost on how to do the regression? We okay on that? So once you work through this, you should get that regression. I'm kind of speeding you up because I don't want to run out of time, and I am making a video for this. So, yeah. What's weird about this equation? Anybody know what this E means? Okay, that's scientific notation. That's the way the calculator does it. So that E means that really this decimal place right here needs to be moved because it's negative 13 spots this way. And if I were to move that 13 spots, if I come down here and I go 9, 6, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and said that, if this was how much money I owe you, how much do I owe you? Not even a penny. Not even half a penny. Okay? Like a couple molecules of a penny, right? And if I was like, come on, dude, you owe me this much. I've been waiting for it. You'd be like, here, take a penny and never talk to me again, right? Because, yeah, exactly, keep the change. So what would you say this number is really close to? It's very, very close to 0. So when you see this negative, if it was -9, if it was -5, if it was -25, this really, all this means right here is 0. And it was a minus. It doesn't matter with 0 whether you add or subtract it, but really that's just a 0. Get this junk out of the way. Okay. There's our model. That's one thing that threw people up, is regression also means model, right? I might say give me a model. I might say give me an equation. What can I spell today? Okay. That means do regression. So there's our model. Questions on this thing said, it didn't even ask for the model. I think on the test it probably does. If a field goal is 10 feet high, if this is 10 feet right here, do I make it assuming that the kick is straight? What I mean by that is when you kick a football through a field goal, if I kick it this way and it goes far enough, goes out of the stadium, it does me no good because I kicked it the wrong way. So when I'm saying straight down the middle, we have to figure out what happens at what point. 42. So basically that first question asking did we make it is saying at 42, how high is it? We got to kick it that distance. And all this model only tells me distance versus height. So I can tell you all kinds of things about, oh, at this distance it does this, at this distance it's this high, at this distance it's this high. I can't tell you how long it's going to take time-wise. I can't tell, like, once they kick it, is it going to get there before the 4 seconds? Of course, if you know anything about football, it wouldn't matter. Okay. Is he going to get more points because he kicks it further? I can't tell you anything about that. Okay. But again, if you know about football, you know that it's going to be 3 points. So we got to plug 42 in here. Y equals negative. The biggest mistake I saw people making is they put this decimal in the wrong place. Okay. So we got to be careful. And then I don't really even have to write the 0. What do I get there? 21. Okay. So the answer to this is 21. So in terms of our chart over here, that means 21. Is that a field goal? Yes, because it had to be what? Higher than 10. Okay. If this answer here was 9 or lower, or 10 or lower even, then it would have hit right here and not gone in. But 21, it was way up here. Did great. Good job. Okay. So the question asked, did they make it? The answer is yes. The question asked, how high was it when it got to the field goal? It was 21. Okay. And then finally, they threw in this curveball that said, what was its highest point? 90% of the time, when they ask a question, the first thing you should try to think about is the what? The vertex. What is this highest point? What's it called? The vertex. Okay, so that last question, which blew people's mind, was saying, how high does this thing get? Well, the height, the maximum, is its vertex. How do we find the vertex? What form is this in right now? Standard. So we use the trick to get the vertex out of it. What is our trick for that? Negative b over 2a. Okay. Comma, I don't know. So in the calculator, you would type in negative 2.6 over 2 times negative 0.05. And I think we'll be surprised that we get a nice number. What is it?
33.8.
No, that's not 33.8.
Oh, 26.
26. We get 26. So our first part of our answer is 26. We plug that back in to this equation for x to find the other part. And we get 33.8. So this question, and just so we know, we can throw this thing over here onto the, oh dear God. We can throw this over here on our table. I'm just going to kind of rewrite it. 26, 33.8. Okay, and again, because I labeled these things, I can answer the question. It asked, how high was it? Okay, and how do I know it's not the 26 number? Because the 26 number has to do with distance, okay, where this is the height. So I can say now, I can add this point here and say that this is 26 and this is 33.8. Okay, and for this kick, we could do all kinds of adjustments. If this kicker always kicked this way, we could adjust and figure out, I don't know if we wanted to for fun, because I know you guys like this, we could change this number to 42 and see if they can make it. We could keep plugging different numbers in here to see how far we can get away and still get a field goal. Woo! That was longer than I wanted it to be. There's a lot of things to a lot of this, right? I don't think any of these different things are hard, but if you don't know what you're doing, they're impossible, right? So please, 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 please study, 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 study. Okay, again, test is tomorrow. People who studied did really, really well. People who didn't study did really, really bad. If you want to watch this video again, you can watch it on YouTube, or not on YouTube, it'll be on the website.